the gas lines disappeared. People went back to driving their cars. And even today, they don't ask where we're going to get the fuel that driving a Tesla using electricity. You ask, where does the electricity come from? Well, plug in the wall. Not enough. Whether you believe that climate change is a naturally occurring, or you believe that it is caused by mankind through the burning of coal, natural gas, and oil. Burning them releases carbon dioxide by emission of billions and billions of tons of carbon dioxide. We have changed the atmosphere, I believe, to a degree where the temperature is continually increasing with possibly catastrophic consequences. The sun is predicted to shine at this rate for another 5 billion years. So we don't have to worry. If we could find a way of using it. Well, we have found a way. Solar cells, wind turbines. But the silicon solar cells only convert 15% of the energy and the light to electricity. And we can do better than that, theoretically. Now, the sun gives us enough power in 1 hour to last all of us for a year. The sun is very powerful. So, in theory, it's possible. But in practice, it turns out to be very difficult. And then there was the discovery of graphene, which is a nanocarbon material. So when that came along, with my background in that general field, I became entranced with the remarkable properties of graphene and recognized that it could serve as the active optical material in an exotonic solar cell, which is a new concept in solar cells that would be much more efficient in the conversion of light to electricity than silicon cells. And that has occupied me for the last more than 10 years. Well, I personally believe that graphene could be the answer, and part of that belief is based on the fact that I've been involved in nanocarbon work from the beginning. I recognize that the discovery of nanocarbons marked a real change in the way in which carbon chemistry will be viewed. And when graphene was discovered in 2004 by Gruen and Novoselov, for which they described the remarkable electronic structure of this material, which is driven by the fine structure constant that allows graphene to absorb light of all wavelengths that come from the sun. And so massless fermions, the electrons in graphene that behave as if they had no mass, are as close to being light waves as being photons as they are particles. So they are the exemplar of particle wave duality, which is at the basis of all of quantum mechanics. So our experience has been over the years that knowledge that we have gained is so large that we can undertake this, an attempt that should be made, in my opinion, in order to be able to meet this, I believe to be very great challenge that faces all of humanity in the future.